And under decimals, children, today we are doing dividing part 2. Decimal division part 2, the ugly sequel. Part 2 has to deal with this, children. This is dividing decimals by decimals. What happens when you divide a decimal by a decimal? And let me give you one and then we shall talk. Let's say you have 0.6 into 1.44. 0.6 into 1.44. The difference in what this is than what we've done before is before we always were dividing by a whole number. Now there is a decimal there. Okay? This is bad. Bad, 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 bad. And the little phrase, when this happens, you think of this phrase, and this is not mine but the book's, you just think of the book. The book says over, over. And that'll help, that's your phrase that pays. Remember the dividing decimals by whole numbers was just bring up the decimal? This one is you have to start with over, over, then it goes to bring up. And what that means is simply this. The simple fix for this is this. I don't want a decimal here. So I just, because I can, move the decimal all the way to the right, okay, and make it 6. But notice how this says over, over. That second over means this. If you move this over one place, you must also bring this over one place. They both get moved the same number. You can't do one without the other. They're two peas in a pod. They're friends. I don't care. However you want to say it. So this changes to be a 6. This changes to be a 14.4. And then once you have that decimal out of there, then you can go to the just bring it straight up part. You move it straight up to here, and you do your division. 6 goes into 14 twice, and then it goes into 24 4 times. Nothing left over. 2.4. So decimals by decimals are over, over. Now let me caution you, children, okay? Let me caution you in this fact right here, okay? If I have 0.2 divided by 0.4, or if I have 0.4 divided by 0.2, you really need to figure out which one goes where when you write it out as a division problem. The place I see most people make mistakes is they don't know which one goes on the outside of the little division box and which one goes on the inside. Remember, when it's written out in line form like this, when you do the division part of the problem, they flip-flop places. In other words, this one is the one that's the divisor. It's 0.2 divided by that, so when you write it out, it becomes this. The 0.04 goes there, the 0.2 gets put under the little box. Same thing here, because you can do both of these problems can be done. I move the 0.2 outside, and I move the 0.4 inside. They give you different answers, though, much different answers. Let's do them, because I can tell you're mesmerized by that. Over, over means this. I change this into 4. I change this into 2. I put my decimal here. I bring my decimal straight up. 4 does not go into 0. It does not go into 2, but I have to keep adding zeros till it works out. Does 4 go into 20?
Yeah.
How many times? 5 times. So the answer to this one is 0.5. Which makes sense if you think about it, 6th graders, because this is 20 cents divided by 40 cents. Okay, 20 cents is half of 40 cents. That's what this says. 0.5 is half. Now this other one over here, if we do that one out, again, same rule, over, bring my decimal straight up. 2 doesn't go into 0, but it does go into 4 twice. I get nothing left over. The answer to this one is just simply 2. If I have 40 cents and I divide it by 20 cents, I get 2. I can take 2 20 cents out of 40 cents. Okay, but please get it in your head that you need to flip-flop those places. Let's look at a hard one, shall we? Yes, let's look at it. 0.24, no, let's go harder than that. 0.4 divided by 0.05. 0.4 divided by 0.05. When I write this out as a division problem, which one goes on the outside? No, second one. It's being divided by this, so 0.05 goes out here. Under the box is 0.4. Now what has to happen here? I have to move this, look, not 1, but 2 places over, which means I have to move this not 1, but 2 places over. I'm going to have to add a 0 and put a decimal there and bring it straight up. 5 doesn't go into 0, 5 doesn't go into 4, but 5 does go into 40 8 times. Nothing left to bring down, nothing left. This is a big fat 8. How many nickels is what this would really say. How many nickels can you take out of 40 cents? 8. There's 8 nickels make up 40 cents. If nothing else in math should frighten you, this should. Is there something else here? How about this one? 12 divided by 0.3. 12 divided by 0.3. I'm going to give you a second. See if you can figure that one out on your very own lonesome. See what you get for an answer for that. They're not always as they seem. We can answer. Jordan Shaw, what'd you get?
0.4.
0.4. Well, let's see. So, I moved this over here, right? 0.3. So far, so good, Jordan? Put my 12. Where's my decimal in 12, by the way?
In the middle.
No, that'd be 1.2.
After it.
It'd be right here. So, I need to move this one place. I need to move this one place, which makes this actually 120. How many times does 3 go into 120? 4 is 12. Subtract. I still have a 0 to bring down. 40 should have been your answer. How many people got 40? Where did we go wrong? Where did the trails fall off the track? Jacob, where's the track?
I did add the 0.
Yeah, now make sure you do that. These all gotta line up nice and you gotta put zeros in there. How about one more? How about 8.1 divided by 0, 0.09? Let's see what you get for that one. 8.1 divided by 0.09. You got an answer, Victoria?
Yes, but I also have a question.
What's your question first?
So for the first one, the first problem we did, it was, 0, instead of doing 5, we put 0.5. Well, how come for like the ones we did after when we did 2, we didn't like do a 0. I don't know. It says 0.45.
Point me to the problem you're talking about. Let me go back. Is it on this one?
No.
Is it on this one?
Yes. Like 0.05. But then we got the answer of 5, but we just put 0.5.
Wait.
for
Stop. Are you questioning why I moved it 2 places?
No.
Okay, what's your question?
So when we did the first one,
The
we
point
got
4?
the answer 5, like, yeah. Yeah, and then we got the answer 5, but we added 0.5. And we didn't do that for the next one, we just did 2.
Because I didn't have to go any farther. My decimal's right here and I ran out of stuff to bring down. I mean, it would help if I put 2.0?
Yeah.
But that's the same number. Remember, we don't put in zeros at the end of things, we leave them off because they don't mean anything. If it's added decimal, 2.0 is the same as 2. They don't change. Same thing here, I would put zeros at the end because that's simplified there. That's a good question. This one here, we got what for an answer? Kelly?
I don't know if I got
Why don't you
Right.
say it? We don't
but I got 0.01. Wait, 0.01 remainder.
Well, first of all, with decimals, we never get remainders, ever.
That's why.
Did you put the 9 on the outside? Remember they flip-flop places when we do division? When you write this problem out, it should be 0.009 divided into 8.1. That was rule number 1. If you don't do that, you're going to be behind the 8 ball. This needs to be moved all the way to the right, which is 3 places, which means you have to do this 3 places, which means you're going to have to add 2 zeros. So it is the same as 9 into 8,100. 9 doesn't go into 8, but it does go into 81 9 times. And the decimal's way over here, so you have to fill these in because you have nothing left, but you can bring down a 0. 9 doesn't go into 0, so you put a 0. You bring down the next one, 9 doesn't go into 0 again. Your answer should be 900. How many 900s were out there? Yeah. You have a question?
Yeah. On the 0.05 and on all the other ones we did, why we move it 2 spaces?
The decimal has to go all the way to the end. There can be no decimal in here at all, so that means I gotta move it all the way to the right.
Oh.
And however many places I move this is how many places I move that. That is the rule. No decimals ever in divisors. Fundamental rule.